First page. Hey, we're doing the review, I guess. I'm going to let you guys do the vocabulary by yourself. I think it's really important to be able to match the word definition. But on your test, if I remember right, I think your definition, I think they're going to switch these guys around. So you'll have a definition, you need to match the word. I don't know which way is easier. I basically do them the same way. So whichever way works for you, make sure you can do them both ways. Again, your test is tomorrow, but this is where we're going to get started. Next one, this is a kind of a review from earlier on. I just wanted to make sure that everyone can still do this type of stuff. When it says segment MN, basically that means, hey, here's a midpoint. Here's a midpoint over here. Here's an M, here's an N. Midpoint's T. To show that it is a midpoint, what do I need to do? You need to draw little tick marks on there. So it needs to look something like that. And hopefully your handwriting's neater than mine. Mine's been a really bad day. I'm sorry. Two vertical angles. You remember, right? Vertical angles usually have, they're made up of lines like this. Okay. You would just label them. Here's an example for instance, 5 and 6 would look something like that. Okay. RS is an angle bisector of angle QRT. So first I'm going to draw angle QRT. So here's Q, here's R, here's T down here. Okay. If something's an angle bisector, it's going to start at R, it's going to go out this way with a ray, like so. We need to label this S, because ray RS. As an angle bisector, what markings do I need to put on here to show that it's an angle bisector? The arcs, right? Yeah, here's an angle arc, and here's an angle arc. So those two are the same measurement. We'll put little angle arcs in there. You guys are getting good at this. You should have seen this before. This should be a nice refreshment of what we're doing. Okay, plane E. Okay, we draw a plane that looks like a parallelogram. I'm going to label it E. Okay, so there's plane E. I said that AB is parallel to this thing, so I'm going to draw a little line on here. Label this AB. I'll draw another line on here. That's going to be CB. Okay. How do I show these two are parallel? Yeah, I got to draw some arrows in here. So boom and boom. Okay, as long as they have the same number of arrows on there, they're fine. I can draw 2 of them on there as well. Why not program this a little bit later so you guys can measure this angle? It's probably about well, I'm not going to tell you. I know the answer, but drawing and labeling these. Okay, which letter is in common here? U. U's where your angle is going to be. So if you were to draw this, it'd be like U. And over here, I don't know, we'll put T, something like that. You have to use a ruler, so don't do this now. And wherever 60 degrees is, remember you put your little protractor on here like so. You find 60 degrees, you put a little dot here. You lift your protractor off, you basically draw your line through there, and label that E. And it's also a good idea to label that 60 degrees. You guys know how to do that. Number 7 says, given an angle of 125 degrees, what is the supplement? Set up an equation and solve. Remember what that means? We have x plus 125 degrees equals 180 degrees. So we're talking about supplements. Supplements always go to 180. You would then subtract 125 from both sides. X would equal 55 degrees. Is that okay? Okay. I'll let you guys do the complement. What's the only difference with this one? Complement means what? 90. We add up to 90 degrees. So it'll work out the same way. Obviously not the same answer, but the same type of setup as we go along. Is that all right?
Yep.
Excellent. Name this angle in 3 ways. This is a commonly missed question. I think most people were able to do this. They were able to say, hey, that's angle F, E, G. They were good with that. And then some people were able to do this. They were able to do it just backwards. That's G, E, and then F. Okay? And the easiest one is just called angle E, like so. Okay? One thing to note is that E has to be in the middle because it's the vertex. It has to be in the middle. Okay? Determine the midpoint. So basically we're going to add these things together. So that's -5 plus 7 divided by 2. This would be 6. Wow. Plus a -2, I guess, over 2. -5 plus 7 is 2 divided by 2 is 1. 6 plus -2 is 4 divided by 2 is 2. So our midpoint is going to be 1, 2. Is that okay? Am I going too fast?
I understand.
Perfect, Steve.
Well, good. Next question, number 11 says, ray SQ bisects angle RST. Find the measure of angle RSQ if the measure of RS, oh, this is ridiculous. The measure of RST is 48. This whole thing is 48 degrees. RST is 48 degrees. It's basically saying since these two are the same measurement, since they're angle bisectors, you can say they're x and x. You can say x plus x equals 48. That's 2x equals 48. Or when you divide by 2, x would equal 24 degrees. So you would say the measure of angle RSQ equals 24 degrees. There was, I think, 2 questions very similar to that on your test. And people who got them or they didn't get them. So this is the part 1 of the test. Part 2 of the test is basically saying, hey, everything that we did before, as well as this, because I really wanted to make sure that if people didn't do all that first stuff, they were able to still get those same skills. Are we okay? Okay. All right, new stuff here. Given a regular heptagon, A, B, C, D, E, F, G, find the perimeter of the heptagon if DE was 8 inches. Do I have to draw it?
Yeah.
If you really want to, you can. It's really tough to draw, to be honest. Oh boy. No, that's next. No. 1, 2, 3, 4, 6, 7. Those are all the same length. If it's regular, remember all those sides are going to be the same length. Yikes. And what length are all those sides going to be?
8.
They're going to be 8. Okay? So if we're finding the perimeter, one way you can do it is you can just say 8 plus 8 plus 8 plus 8 plus 8 all 7 times, or just do, hey, that's 8 times 7 equals 56. What would our units be? Inches. So 56 inches. That's all the work you really need to show. I don't know if you need to even draw the picture for it, but 8 times 7 is fine. The way you got the 7 is because it's a heptagon, and you know that heptagons all have 7 sides. Alright. 2 words to describe this: a concave pentagon. Okay. The way I've always drawn this, I mean, you can draw it a bunch of different ways. Anyway, that would work out just fine. Okay. When you name this, though, remember you pick one point. Katie, pick a point. I don't care. What do you want? Which point do you want me to use? This one down here? Okay. Where it just says the first one, where are you going to go around? Clockwise or counterclockwise, right, Rashad?
Yeah.
Which way do you want to go? Clockwise or counterclockwise? Clockwise. So P, Q, R, S, and T. Okay. And it says draw all diagonals for point R. Okay. So a diagonal means that it connects any non-adjacent vertex. This is going to look really dumb. So that's one of them, and that's one of them. Ideally, they're straight lines. There should be 2 of them. No matter what point Q or R was at, you'll get 2 diagonals for it. You can't connect the Q because that's adjacent. It's the consecutive one. You can't connect S because that's consecutive as well. Classify triangles. Okay, when you classify triangles, you always classify it by its angles and its sides. Okay, these are for triangles only. What are some of the choices for if something has, let's see, let's talk about angles first. Let's talk about angles. What type of angles could a triangle have? Acute. That means all 3 acute. Wow, I missed a letter. Acute. Acute, so that means all 3 angles are acute. What about, what else? Obtuse?
Right.
And right. Okay? So when you talk about triangles, you have to have one of these 3 terms. Okay? Side lengths. What if there's no sides the same? Scalene. Make sure you know how to spell these words. They should probably be on the very first page of your vocabulary. If there's 2 sides, 2 or more sides that are the same, isosceles, which is also a very difficult word to spell. if they're all three the same, equilateral. Equilateral. Okay, let's take a look at these guys. This first one, biangles, is definitely acute. And then since two or more sides are the same, we would also say isosceles. If you want to draw the triangle symbol next to it, that's totally fine. Acute isosceles triangle. Triangle is the only one that really has a shape that's associated with its name, so if you want to write it, that's fine. Part B, you want to be as specific as possible, so tell me some things that we know. It's going to be acute because all these are 60 degrees, right?
Equilateral.
Okay, it's also equilateral.
How'd you know it was 60 degrees?
Because they're all the same. They sum together to be 180.
Okay.
What else? Oh, it's also equiangular.
Equiangular.
Equiangular. Okay. Now, what do you want to say? If you just say this, all three of these, if you say regular, that's the best you can say. So all you need to do is write regular. Yep, because they're all 60 degrees, all that can be broken down, and we all, all those things are true if you just say regular. Okay, so the best answer you can have written down is regular for that one. Maybe a regular triangle would be fun. Tucker, how would you classify seats? Right? That is correct. Right ceiling. But none of the sides are the same, so it's right ceiling. This worked. Okay, we're doing well. Classify each polygon. On your test, I think this is question number 14 on your test. There's one error. They actually draw lines in here. Say, hey, you need to do this 2 different ways. There's one of them. There's 2 lines. So there's only one word you can use, and I'm going to tell you about that. And you're going to think it's really dumb, but I don't know. There's only one word. So for shapes that aren't triangles, generally speaking, you talk about them being either convex or concave. Okay? So let's go through. Is this convex or concave?
Convex.
Okay, this is convex. Wait a second. That's concave because there's little inlets here. These make it concave. Okay? And how many sides are there? There's 12 of them, so we'll say dodecagon. Make sure you count it correctly. Okay. Now for this one, there's only one word to describe it. If you really wanted to say convex or concave, I guess you could. I could make it a second word. So is this convex or concave? It's convex, because there's no indentions. And then what about this thing here? These 2 lines make it parallel. So is it a parallelogram? Are these 2 sides parallel here?
They're not.
They're not, so it is a quadrilateral. You can be more specific. Trapezoid. It is a trapezoid. Trapezoid has exactly 1 pair of opposite sides congruent. Or, I'm sorry, parallel. Trapezoid. Which ones? These 2 here?
Yeah.
They had arrows on them. If you were to rotate it, all it would do is it would look like this. They'd be like, dude, that's a trapezoid.
Okay. I see.
You have to kind of visualize. You have to sort of turn in your brain.
Oh.
Okay. This guy right here. I don't want you to say convex or concave because we can be more specific with this. What's going on? Equiangular. Equiangular pentagon. Part D. Part D. Equilateral. And how many sides are there? 8. So that'd be an octagon. I think we're doing pretty good on this. Oh boy. Something you just have to memorize. This is on the test. It's pretty easy points. It's worth 7 points. If you wanted, you could switch these two guys around. It doesn't make any difference. If you wanted, you could switch these two guys around. It doesn't make any difference. Those are the two that basically I would check to see if you have those in the right spots. Everything else needs to be within one spot. It could be. But I'll let you guys fill that out. I'll give you a first letter for each one of them, I guess. That might work. That'd be really nice of me because this makes it very easy, except for these two down here. So that you give it pretty much away. It is multiple choice or matching, I guess. I don't know if it's matching on the test or not. If it gives you the words, make sure that you spell them correctly. If it is not multiple choice or matching like this, make sure that you know where all these things go. Okay? Just make sure you know where they go. You all right? Can I move on? I'm moving on. Okay. Holy smokes, I went way too far. Okay. Draw an example of each of the following. Here's the key part here. Include proper and accurate markings. So remember all that crap we talked about last week? It all needs to be on there. Pick one of these. Which one do you want me to do? Someone said trapezoid. I can do trapezoid. That's the easiest one for me to do.
Really? Oh my god.
Trapezoid.
You guys are like,
Boom, boom, done.
seriously.
That's all I have to do for it. Okay? Trapezoid's the easiest one. The rest of them, there's tons and tons and tons of stuff you have to put on there. Make sure you have the opposite sides, opposite angles, something about each of the side lengths, if things are parallel or not. There's tons and tons and tons of markings. Some of them have 90-degree angles. Make sure you have all of those in there. Okay? Give an example of each of the following. Is there more than one example of each? Probably so. Yeah. They don't need to be. What's that? They don't need to be. They can be.
It's hard to see most of the time whenever I'm trying to pick up stuff. And so I'm like, what happened? No, I know. You can pick up stuff. There. I'll just sit there next time.
All you do is just turn sideways and then just make sure you're writing sideways with it too. Central angle. Silence, give me a central angle. F and E sounds good to me. F, A, and E sounds good. Let's see. Christine, give me an example of a radius. A is a point. So AF, that would work out perfectly. Is there more than one example? Sure. There's tons of radii up there. Diameter, let's see, Mitchell, give me a diameter. You'll have to name it with 2 letters if it's this. Make sure you have the right markings on it too. There's an angle, there's a line segment, there's a line segment. A tangent is actually a line. I only wrote a tangent on there. There's a tangent line. Rashad, I don't even know what I was saying. Rashad, can you tell us a tangent line?
I know.
What's that?
Okay.
Okay. You need 2 letters for it though.
EJ.
EJ. So you say EJ, and you have to make sure that you write the line symbol on top. Has to have a line symbol with the 2 arrows on it. Minor arc. Minor arc, please.
BG.
I'm sorry, what was it?
BG.
You remember minor arcs, you only need 2 letters on it.
BG.
So BG. BG, make sure you put a little angle arc on it. That would work out fine. There's tons of them though, yeah. BC would work, yep, that's only here to here, that's fine. You could say B to H, B to F, you could say F to E, F to H, F to G, F to B, F to C, no, F to C, that's semicircle. F to D, D to E, there's tons of them, there's tons and tons of them. Okay, major arc, remember you need 3 letters for any major arc as well as a semicircle. FED only goes from here to here. So what if we do FD and then end up with over there?
FDC.
FD, FDB, FDB. Okay, so it started here at F, it would go through D, and then we go end up here. That is definitely a major arc. Okay, semicircle. There's only 2 of them I can think of, but there's several different ways you can name them. Tyler, name me a semicircle. Yes, please. Three letters for a semicircle. G. So you're going to start at G, you're going to go C, and end up at E. Well, remember you need a diameter that goes across it. So I think you have to start off with a diameter. Yeah, C, D, F. C, D, F. That would work. C, D, and F. So the D is what tells you what direction we're going. We just said CF. We don't know whether we're talking about the top or we're talking about the bottom. Because you need three letters for a semicircle. C goes through D, ends up at F. Is that pretty much it? Oh, there's one more. Did we finish talking about this on Friday?
No.
Okay, I think the bell rang. So let's chat about that right now. If this is 67 degrees, this angle, this arc right here is also going to represent 67 degrees. Okay? So, that's 67 degrees. So all we have to do is say 3x plus 10 equals 67 degrees. How do I solve for x? Subtract 10. Again, I am showing off the work here. So 3x equals 57. And what? Divide by 3, divide by 3, and x equals 19. Okay? That's really good. Let me change it though. I'm just going to do a problem here. Okay. I'm going to say this whole outside part is going to equal 3x minus 6 degrees. So I'm sort of changing this problem. How many degrees is this entire outside part then? So the whole circle is how much? 360. And if I subtract 67 from that,
293.
so that's 293. So that 293 is going to be equal to 3x minus 6. Okay, could you solve it from there? Yeah, I'm sure you can. You add 6 to both sides. It doesn't come out nicely. I really wish I would have picked something that would have worked out nicely.
Did you say no?
You would divide by 3 and no. That would have been really nice if it would have worked out nicely, but we're at 99 and 2/3. Yeah, that's kind of gross. But okay, you get the idea though. So the idea is that if we know this is 67, that's representing, this 67 represents that much. We know the rest of it is basically just 360 minus 67. Okay? And that's going to be represented by this stuff here. Those are basically the two concepts that I need to talk to you about on Friday. Okay? You guys have until, what, 10:19 to study for this. Please avail yourself. Someone's going to pass out some protractors for us. We're going to be able to do some work on this.